So we've talked about a couple of different types of contact forces. Again, an applied force, which can be a push or a pull. We've talked about normal force. We've talked about tension. The one we have not talked about too much yet is friction. And one thing I want you to think about is usually when we talk about friction, there's actually a couple of forces or a couple of places where friction is applied when we just kind of lazily talk about friction. I'll illustrate what I'm talking about. When we have two surfaces that are sliding, or when we have a block sliding on a surface, for example, even if they seem to be pretty smooth surfaces, on a microscopic level, there's all kinds of nooks and crannies, both in the surface that the object is sliding on, and even the bottom of the surface itself. So I like to imagine that my hands are like microscopic views of those rough surfaces. And when I put my hands together like this, if you try to slide your hands past each other with the knuckles kind of intertwined, it takes some effort. There's some resistance there. That's what we call friction. And it turns out there's actually two frictions that are going on here. When I've got I'm going to call this my block, and this is going to be my table. When I've got my block on my table and it's sliding along here, there's actually two forces that are going on. I can feel the knuckles from my top hand pushing on my bottom hand in this direction. But in a similar way, or at the same time, I can feel the forces of my bottom hand, the knuckles from my bottom hand, pushing on the knuckles of my top hand in this direction. So notice there's actually two frictional forces acting on there. The force of the bottom hand on the top hand in this direction, and the force of the top hand on the bottom hand in this direction. And knowing that there are two forces acting, and notice that they're on different objects, the force of the bottom one is acting on the top one. The force of the top one is acting on the bottom one. So that's very, very key in understanding how to use friction in some of your free body diagrams. One thing I do with my traditional classes quite often to illustrate this is to get some toothbrushes or some metal brushes, and we intertwine. I don't have toothbrushes handy, but this is a little kitchen brush. But if imagine I had a second kitchen brush shoved underneath here with the bristles intertwined, and I started pushing on one on the other. Well, first of all, one thing you should notice is right now the bristles are just hanging around. They're not doing anything, right? They're not moving. Then all of a sudden, what happens? When I do this, they bend. And if you're starting to think like a physicist, when you see those bristles bend, you should automatically be asking, what's forcing them to bend, right? Bristles don't just bend because they feel like it. They don't just say, okay, let's all bend. They bend because they're being forced to. In this case, it would be the force of the bottom bristles pushing on the top brush in this direction. But of course, if I had two brushes intertwined, when I do this, the bottom bristles would bend in that direction because they'd be forced to because of the top bristles. So I encourage you to get a couple of toothbrushes and start playing around. Watch those bristles bend, see what the directions are, and see if you can assign the cause of that bend to one brush or the other.